Well done. Because we're running a bit out of time, we're gonna jump into the CPD presentations, continuous professional development. We'll ask you if you wanna go grab a coffee and come back quickly, you can feel free to do so. The first CPD presentation is by Majid Lewis, Managing Partner for Implement Engineering Consultants. He's a mechanical engineer with 35 years of professional experience, including 27 in the UAE, quite a lot. He has participated in the design and construction of numerous projects, including super high-rise towers, hospitals, hotels, educational facilities, and performance in life cycle economics. He is known for providing innovative, out-of-the-box solutions to solve difficult problems and to improve buildings, performance, and life cycle economics. Please allow me to invite to the stage Majid. Thank you.
Good afternoon. The presentation will take an example of value engineering on an actual project, which is about air conditioning, but it is not to discuss the technicality of the air conditioning rather than to evaluate the concept of doing value engineering and how value differs from whichever perspective you are looking at. So what somebody's trash would be somebody else's treasure, and how to present the value engineering to the client as a contractor so that it's a win-win situation rather than the client is looking at the contractor as if he is trying to deprive him from the value he is paying for by giving him a cheap product. So on that project, we have taken a different approach, looking at the design and how we present it to the client. Most of the presentation is taken from the actual presentation done to the client, where the client has been happy with the value delivered to them to the extent that they were not so keen into getting any cost saving against what was saved by the contractor. So an important message here is while we discuss, we might criticize some of the design decision taken. For that purpose, I do not like to disclose the name of the project because we are not here to criticize people's work. We are here to get the lessons learned and to use from the value delivered by the design. So the project is a big hospital, and we are only taking a small portion of the value engineering done for the 5 floors above the mechanical floor, which are all for patient rooms. So we will discuss some information about that mechanical floor where the louvers are and the typical floors above. Overview of the project. It's the size of the floor can take 3 football courts, just to visualize the size of the project. And it's 9 billion budget. 20 tons of cooling capacity with a chilled water header is 1.1 meter that you can crawl inside the pipe. And only 27 tender drawings for HVAC. That just to show how little is the information given to the contractor in the tender stage, showing them what they need to do. That's just an example. Sorry if I'll try to limit the need to point to the screen, but at some time I need to point to something. Sorry, I will point to one screen only, and sorry for the guys on the other side. So that's typical. The hospital is 4 wings like this, and every wing is 22 patient rooms. And the designer told the contractor, I need to put 2 air handling units in every machine room for every typical floor. So these 2 machines for these 2 wings, 2 machines for these 2 wings, and so on. Supply duct is running in the corridor, return duct is running inside the rooms. So given to the contractor, and the contractor has to take this and put flesh on the bones and start detailing it. So we'll just take a section through this corridor here, showing the supply duct, return duct going through the patient rooms, and how we come to evaluate the design to present to the client that there is a better value if we revisit your design. So on that section, obviously they had to put the return duct inside the rooms because there is no space in the corridor to accommodate the return duct. And of course, it's bad engineering to run the return duct through patient rooms because some patient would be screaming in pain or some patients would be laughing, watching TV, and the noise would travel from one room to the other. But obviously, they did not have another option because there is very limited space in the corridor outside. Also, having that return duct had to push the supply duct to the VAV through this S offset, which is not very efficient for the VAV to get proper control due to the vibration or the turbulence happen at the entry to the sensor of the VAV. So, also when you look at one wing, the size of the length of the duct going all the way to the end of the wing and coming back again, like one air handling unit has to push the air through 1/4 kilometer of duct run. So that is quite long for the duct to travel, which requires the fans to be very big and consume a lot of energy, giving the pressure we need. Looking at the mechanical floor here, where the louvers are, you can see this red cavity here, which is just a fresh air intake plenum. The designer very nicely allocated 3-meter wide cavity next to the air handling unit so that any air handling unit that needs fresh air can take it from the nearby plenum where there is a louver outside. Very convenient to the mechanical designer to find fresh air whenever you need it. But looking at the plan of the mechanical floor, these are the 4 wings, and this is the backside. The total length, like this piece, is 43 meters long, just to visualize the size. So the total length of the plenums is 1 kilometer in the hospital. And looking at the width of that plenum is 3.7 meters. The height of the floor is 3.9 meters. So the square meter area of these louvers is 3,900 square meters of filters and of sand traps, and 3,800 square meters of built-up area that is occupied by nothing, just empty box. So this is equivalent to 120 patient rooms. So until here, we are just telling the client that we looked at your design and we think that you have wasted a lot of value. You are building a lot of empty boxes here that we can convert it into an actual value to you. So you do the math, you need 451 technicians, assuming one filter needs 10 minutes to take it out, wash it, and put it back again. So for all 3,900 square meters of filters, if you have to wash them within 4 hours every time you have a sandstorm, the client has to keep an army of 451 technicians just washing filters. And that is not very good operational figure to the client. So we listed the points of concern to the client so that when we come with a solution, the client is receptive to finding solution to his problem rather than just looking at this contractor is coming to cut cost on my project. So space limitation in the corridor. If you put the supply duct in the patient room, you still have a lot of other cable trays, containment pipes, and other things. So coordination was a nightmare there. Return duct running through rooms. We mentioned about noise traveling between rooms. Machine rooms are very tight, having these 2 air handling units inside this machine room. The offset before the VAV, we mentioned is bad control. 2 long ducts, the 1/4 kilometer we mentioned about. Some VAVs near the air handling unit will have high pressure because they are very close. And some other VAVs at the end of the line will starve, will not get any pressure. So the fan has to run at full speed all the time to cater till the end of the line, which is poor energy efficiency. So there is no place for sound attenuator because of so many bends, and sound attenuator needs a straight run to put the sound attenuator. And there is no redundancy. If you lose one of the air handling units, you lost half a wing that you cannot supply air from one unit to the other unit. And redundancy in hospitals is a very good value. Clients would pay money to get it. And if we can deliver to the client a better design by providing redundancy, the client would be willing to give away some of the value we are saving. So there is no control on the fresh air mix because fresh air is directly inhaled from this plenum outside. And there is the 1 kilometer air plenum and sand traps and washable filters that is very costly to maintain. So now the approach for the design. Until now we did not discuss what did we do for the design. But very important aspect when we come to do value engineering, that some people often take an isolated approach. Like the project manager tell the mechanical engineer, here is your mechanical system, do me value engineering. And the electrical guys, here is your electrical system, do me value engineering. And everyone is sitting on his island doing value engineering of his system. It is exactly as if I give you this Rubik's Cube and say, I have done half the job. I solved one phase for you, you just solve the other 5 phases. You cannot. You cannot solve this phase unless you mess up with this first and then you put them together. So sometimes to solve one problem, you might have to change something that does not appear to have a problem. Like the electrical engineer comes and say, my electrical network is fine, I don't need to value engineer it. But the mechanical designer would need to change something which might impact the electrical or otherwise. Eventually, together, they will deliver the value we are talking about. So this is the before situation where, as we mentioned, all the problems that is happening here. And this is what we propose to the client. Small ducts, 750 by 400 instead of 150 by 750, and straight run into the VAVs. So how can we supply that amount of flow rate into that small duct so that we can fix the supply and return ducts inside the corridor and come with such a clean arrangement? So we came with the proposal of putting a ring around the corridor and injecting air into the ring from vertical riser, 6 points of injection, of injecting into this ring. So that has turned this supply duct coming here only feeding 3 VAVs on the left, 3 VAVs on the right. And then it meets the air coming from the other end. So instead of having the fan pumping air to 120 meters away, now this fan here at the bottom is feeding only 4 meters, 5 meters away. So on the mechanical floor below, when we taken away the plenum that was taking all the space around here, we availed the space to place 6 air handling units in the mechanical floor, conveniently located under the shaft so that the fan is pumping directly into the shaft, vertical duct. So in section, this is how it is located. The fan is located under the shaft, sound attenuator is directly in a straight run, and the branch going into the ring inside the corridor. Instead of the big plenum that was occupying that space, we have put a fan-powered VAV here, which is controlling the amount of fresh air we need to inject into the return air duct. So we have a smaller fresh air plenum, but we have more control on the amount of fresh air we are supplying in. So we are adding value to the client by giving him control of how much fresh air we supply into the building, while we have saved the big plenum that was have to be built here with the filters and sand traps and all the costs there. So if we just cut this and flip it open to look at it in a simpler way, this is how it was. We had 10 air handling units in the 5 floors. Each air handling unit is taking 1 wing with all the VAVs coming out with the very far and very near VAVs. We changed it into this. We have put 6 air handling units, injecting into the 6 risers and keeping these as the rings here. 5 of these air handling units are equal to the 10 air handling units before. So we have put 120% more capacity into the air handling unit. Another value added to the client that we are giving him 120% more than what he budgeted for. And for the contractor, he is only supplying 6 instead of 10 air handling units, but 6 bigger air handling units. So let's look from the client's point of view, how we present to the client the value added to them. Now, there are no machine rooms. All the machine rooms on the typical floors have been converted back into healthcare spaces. We don't need these. Take them back, make them storage, make them nurse stations, make them whatever you like, but we don't need them as mechanical spaces. That's a big value that the contractor did not pay anything to give it back to the client, but the client values this a lot because it's in the healthcare floors and it can be converted into patient rooms or any other things. We now have N+1 active redundancy. The 6 air handling units working together in parallel, one of them fails, the other 5 already senses the failure and ramp up to make up for the failure, and you have the redundancy that you don't lose a single wing by the failure of one air handling unit. No machine room in the patient floors. So these typical floors, they don't have a single air handling unit. So you don't have in the middle of a let's say maternity hospital or maternity wing where it is all restricted for ladies and you have a technician with a ladder walking through the corridor because he's going to the air handling unit. We don't have that. No machines in the patient floors, which is better for privacy and for hygiene and contamination control. Low static, low noise because the fans are pumping into vertical stack with a very short horizontal runs. All VAVs are near the air handling unit because we don't have the long run that was there before. Energy saving, of course. And straight ducts before the VAVs, as we saw. We lost the turbulence that was there. Still more value to the client. Sound attenuators are now in the vertical duct, easy to install, and as per manufacturer recommendation. Accurate control on the fresh air intake. And increased total capacity of the air handling units by 20%, which is again a proposal from the contractor which the client appreciates. And no crosstalk noise between the rooms because there is no return duct passing from one room to the other. All these are values delivered to the client with hardly any money paid by the contractor. This is just what I said, somebody's trash is somebody else's treasure. The client treasures these values, but the contractor did not pay anything to give it to the client. In return, the client saves some money, where this table is how we define the gauge of sheet metal that we use for the ducts according to the duct size and the pressure in the duct. So originally we had a high pressure of 1,000 Pascal, and the duct was 1,500 millimeter, which dictates that we need 1.6 millimeter sheet. As compared to now, we have the pressure reduced to 500 pascals, and the duct size is reduced to 700, so we only need 0.55 millimeter gauge. So how does this work? Like, for the contractor saving, first we save the 1 kilometer of plenum with all the filters and everything. Then reduce the duct size from 1.5 by 0.7 into 0.7 by 0.4. And reduce the sheet metal thickness from 1.6 millimeter to 0.55 millimeter. So adding the total area multiplied by the thickness to find the weight of steel, the steel metal weight is reduced to 17%, not reduced by 17%, reduced to 17%. So like we have cut 83% of the weight of sheet metal the contractor had to supply, while still complying with the code, following the SMACNA standard for the sheet metal. Everything is correct and code compliant, no cutting corner, but a huge saving by the contractor. Contractor supplied 6 AHUs in place of 10, which is saving on the piping, valves, cables, VFDs, sound attenuators, and BMS devices. Although the air handling units are bigger, but this is by the count. It only multiplies by number of air handling units. There is no return air fans because the related power supply, cables, breakers, VFDs, because the fan is now closer to the VFDs, so one fan can push the air back and forth. So we cancel the return air fans with all the chain of VFDs and other devices feeding it. Shorter AHU because we cancel the return air fan. Simpler coordination. Larger space in the mezzanine floor to accommodate all the AHUs. As we said, we canceled the plenum around here, so we gained enough space. Before, when the plenum was there, the leftover space was just a corridor that is not good for anything. No chilled water piping above mezzanine floor. That is a very good value to the contractor, that by the time you reach the mezzanine floor, you can finish your piping. You can start flushing the pipes. You can start your commissioning of air handling units while the civil contractor is still building the structure. You don't have piping above the mezzanine floor. So this is a huge saving to the contractor, that you do early completion of the air handling unit installation, piping, flushing, balancing, while the tower skeleton is still under construction. Easy commissioning, self-balancing of the system, guaranteed fresh air to all the loads. And of course, early completion is money to the contractor. So, of course, when we present this from the contractor to the client, we don't go through the savings to the contractor. This is hidden in the contractor's sleeve. But by the time you have developed all the savings to all the value added to the client in the previous 4 slides, the client has already bought your design and is not interested to look at how much did you save by doing this. And that's exactly what happened. At the end of that presentation, the project manager and the cost consultant, doing his job correctly, he stood up and say, I see you are saving a lot of money. Are you offering this with cost saving? And before I answer, the client cut him and said, I'm happy with the solutions provided. I don't mind if they save money. I'm not after cost saving here. So that was the win-win approach, that don't just look for how can I cut corners, how can I make the sheet metal instead of 1.5 meter, let's make it 1.4 and still be within the code. That is very minor saving, and when the client does not feel any value added, he comes back and say, I can allow you to do this if you share the saving with me. And then it becomes a fish market negotiation, who takes what. But when the client gets away with a lot of value added that did not cost the contractor anything, then the client would be willing to let the contractor also get away with the savings that he has done and the good engineering that he has provided. So what applies to HVAC applies to any trade. If you look at how can you deliver value to the client while you are saving, you are removing one column to make it the beam of a longer span, but saving the column and steel and the foundation and everything, then you sell the client that I'm giving you a column-free space. So the client gets this as a higher value and allow you to cut that column as long as you are going to do a different design of the beams or different arrangement, and so on. So that is the win-win approach that we take in looking at the design and build. And again, this does not happen on system by system. This happens as a holistic look at the entire project, because sometimes when you are doing this, you have increased one cable size, or you had to put one extra VFD or something, so you pay in some area and save on some other area, and the overall look is delivering higher value and saving the cost. So, questions? Thank you.
Thank you.